Okay, so here we have a quadratic plus another quadratic. Polynomial just means more than one term of things that are multiplied, that each term is separated by addition and subtraction. So here, this is a polynomial plus another polynomial. Polynomials just means terms that are added or subtracted together that do not have division by a variable involved. That's what rules for polynomials are. So no negative exponents or no division by the variable, which we shouldn't have to worry about too much, okay? All right, so this one we're looking, when we're trying to add and subtract things, what do we look for? Like terms, exactly. That's exactly it. It's nothing different than what you did in junior high. It's just we're dealing with higher exponents here. So we look for like terms. This one probably, this is algebra 1 type example. We got x squared plus 3x minus 5. Is there anything in the other polynomial that looks like x squared? Yeah, so we have x squared plus 3x squared is 4x squared. So that gets rid of those. And you can mark them out if you want to. You don't have to. I do the first example that way, and then I kind of quit because I don't ever do it that way. But it just helps you to say, okay, I've used that already. I'm not using it again. Then we have a 3x. What's like 3x? Negative x. I'm doing 3x, positive 3x plus negative 1x, positive 2x. So those are done. And then we have negative 5 plus positive 7, plus 2. And you've added 2 polynomials. Been adding polynomials for a long time. We probably never we just didn't call it polynomials. We called it putting like terms together. That's what we did.
So is this probably going to be later, but will this also involve, like, you have to add the polynomials and solve it?
That'll be later on, not today. Yeah, but later on we'll do some stuff with solving polynomials out of there. So let's look at this one. 3y to the third minus 2y squared minus 7y plus negative 4y squared minus 5 plus 2y. So again, 2 polynomials. We're adding them together. We're adding because there's a big plus sign in between. And when we're doing this, they don't necessarily have to start in the right order. But when we get finished, we want them in the right order. What do I mean by right order? Descending order. Yeah, the same with as we did with quadratics. We're going to go biggest power and go down. We're going to do that with our answers here. They're not always going to start. I know the first polynomial is in the right order. The second one is not. Don't necessarily have to start in the right order. We just want to finish in the right order. Okay. So what's the highest power on the variable? The third, y to the third. Is there anybody that's like y to the third? No. So we're just going to bring him down. Or her, I'm not sure. What that is, but it's a y, so probably her. All right. Now, so that one's done. Then we go to the next term, negative 2y squared. That's the next highest power. So is there anything like the y squareds? We got a negative 4. So negative 2 plus negative 4, negative 6y squared. Easy stuff today so far. And then negative 7y, that's the only thing left in this polynomial. So negative 7y goes with plus 2y, positive 2y. So negative 7 plus 2, negative 5y. So that's everything in this first polynomial. So I'm done, right? No, there's a piece left. Right there, that minus 5. Nobody else like it, right? Bring on down. Make sure you're in descending order, cube, squared, plain number. So make sure you're in that order at the end. Do this one. Let's say we had 5y squared plus 6y plus 7 minus 3y squared plus 8y minus 6. So we're subtracting this time. What's the only difference? You're subtracting instead of adding. Like terms are still the same, no matter what even though we're doing the opposite operation. So we start with the highest power of y in this one, since y is our variable. So y squared, 5y squared minus 3y squared. 2y squared, right? Then we go down. The next is plain y. Positive 6y minus positive 8y. Negative 2y. And here's where it gets tricky, and everybody always misses it on these signs. Signs are most common mistake you guys make, and you're not the only ones. It's the most common mistake in any math class from anytime you start dealing with positive and negative all the way through differential equations. So next, positive 7 minus negative 6. Double negative, 13. We subtracted two polynomials. Easy stuff. Keep telling yourself that. Keep telling yourself that. Out of nowhere, it's going to be Algebra 1. It's like everything else. All right, this one, same idea, two polynomials, subtracting. And again, we want to end up in descending order. So first polynomial, we got a y squared, it's the biggest one there. Second polynomial, what's the biggest one? We got a y cubed. All right, so that means we need to start with that one. Bless you. Bless you again. All right, and then, so what's the y cubed going to be? But it's minus negative 6. So it ends up being positive 6y cubed. Easy stuff, right? And then we go to the next power of y, which is y squared. So we have negative 8y squared minus 4y squared. Negative 12y squared. And then we go to plain y. 6y minus 10y. Negative 4y. Then regular numbers, 11 minus negative 8. 19. Got to be careful with signs, especially the subtraction problems. That's where they're going to get you with the subtraction on the signs, the double negatives. Just be careful with those. All right. Let's do a little bit of multiplication here. And this is definitely what we've done in the last few weeks. So we'll introduce with that. That's a polynomial times another polynomial. Multiplying out binomials there. They're binomials because they got two terms. But it's a polynomial times a polynomial. How do we do that? Distributive property. X times both of those terms, and then 4 times both of those terms. Okay? So x times 3x. 3x squared. X times 5. 5x. And then we distribute 4. Positive 4 times 3x, 12x. Positive 4 times 5, 20. And then we go back to adding and subtracting polynomials. Okay? Put the like terms together in the middle. 3x squared plus 17x plus 20. And that's where you're finished. You're not breaking that back apart because you'll end up back, if you do it right, you'll end up back at the original problem. You're multiplying those out together. So that's where we've been. Let's get to where we're at. Bless you. So very similar looking problem. The only difference is we have bigger exponents. So we're dealing with higher degree polynomials this week. Okay. So this doesn't look much different than that. So it would make sense that we do this the same way, right? Distribute x squared to both terms. Then distribute positive 4 to both terms. Okay? X squared times 3x to the third. 3x to the fifth. Goes back to that rule about exponents. If you multiply, you add exponents together. Okay? And then x squared times 5, 5x squared. And then we're going to distribute the other part. Plus 4 times 3x cubed. 12x to the third plus 20. All right. Are we done? No. What do we got to do? Put in descending order. 3x to the fifth, 12x cubed, 5x squared, plus 20. Didn't have any like terms there because everybody had a different exponent. You got to have the same letter or letters and the same exponent to be like terms. Okay.
So will putting it descending order at times requires some like product of some
Operation.
Positive and negative manipulation.
No.
Okay.
If you're just changing the order in which it goes, the sign stays with it.
Okay.
So if it's a negative, if it's a minus 5x squared and you need to move it up, it stays a minus 5x squared. It never changes. That's a good question. It's a really good question. Let's see here. Let's square something. Let's make that 4x to the third plus 5y. And let's square that. That's definitely a higher degree polynomial. What's it mean to square something? Multiply it times itself. So this is really what's happening. That's really what's happening. Okay? Don't fall into the trap of just squaring each term and saying you're done. Because if you square 4x cubed, you get 16x to the sixth, which is part of the answer. And if you square 5y, that's 25y squared, which is part of the answer, but that's not the whole answer. Okay? You've got to multiply it out and get those terms in the middle. Okay? Anytime you're squaring a binomial, if you're squaring a trinomial, you can't just square each term. You've got to multiply it out. And that's where one of the reason I do an example like this is because that's where most of us will miss some of these problems is when we just square the term and don't do the middle parts. So the middle parts come from that distributive property where you're distributing 4x cubed to both pieces. That'd be 16x to the sixth, 20x cubed y. You got two letters, you just put them both on there. You can multiply, there are no rules as far as being able to multiply things together, only rules about adding and subtracting things. Like terms only exist for adding and subtracting. Multiplying, you can multiply any two things together. Okay. All right. Then let's distribute the 5y. So we end up again with 20. I'm going to put x cubed y. Doesn't matter what order I write that in. I'm writing it x cubed y because that's the way I wrote that one. Doesn't necessarily matter what order. I tend to stick with alphabetical order. But that's, and then 5y times 5y, 25y squared. Not quite done. We got like terms, right? Both of these pieces in the middle are x cubed y, so that means we can put them together. So when I put these together, it's positive 20 x cubed y plus another 20 x cubed y, which would give us 16 x to the 6th. Then what? Yeah. Make sure when you do that addition, you're not changing exponents. I'm getting that idea of multiplying, and you want to change those exponents, but you don't. When you're adding and subtracting, combining like terms, don't change your exponents. There we have an example of squaring something. Let's take a monomial like negative 3 x to the 4th times a polynomial 2x to the 3rd minus 5x squared plus 11x minus 9. What property is this? Distributive property. We're distributing a monomial. It's a monomial because it only has one term. M-O-N-O, that prefix means one. So there's only one term here. We're distributing this monomial to this polynomial because it's got more than one term. Okay? So negative 3 x to the 4th times positive 2 x to the 3rd. Oh, I know, negative 6 x to the 7th. Okay. And then the next piece, negative 3 times negative 5, positive 15 x to the 6th on this one. The first one's going to be 7 because it's 4 plus 3. Second one's going to be 4 plus 2, 6. What's the third term? Negative 33 x to the 5th. Last term. 27 plus or minus on that. So it's in descending order. There are no like terms to put together. Not hard stuff. It's not what I would call rocket science. It might lead to rocket science. Let's take something a little bit bigger. Let's take 2x squared minus 5 times 1 plus 3x squared minus 5x. One plus 3x squared minus 5x plus 2x cubed. So how many times am I doing distributive property here? A lot. Technically twice. One for each term of that first polynomial. Okay? It's a lot of terms to multiply together, and we're going to have to make sure, at some point we put it in the right order. So I'm just going to start with the first one, 2x squared times everything in the parentheses. 2x squared times 1, 2x squared. 2x squared times 3x squared, 6x to the 4th. 2x squared minus times a negative 5x, be negative 10 x to the 3rd. And 2x squared times 2x to the 3rd, 4x to the 5th. So that's the 2x squared times everything. Now, take the minus 5 times everything. I'm just going to do it in a different color so you'll tell. Negative 5 times 1, negative 5. Negative 5 times positive 3x squared, negative 15x squared. Positive 25x, negative 10x cubed. A lot of stuff there. A lot of places to make a sign mistake, not just in the multiplication, but when you combine like terms, Dan.
Will there ever be a time when we like break that down into like a completely other polynomial?
When we go to when we start solving later on this week, yes. Okay, that's when that'll happen.
Yeah.
Not today.
Okay.
All right. So, what's the name of the game here with purple and green? Putting what together? Like terms. And we want to put it in what order at the end? Descending. Okay. Now, what's the biggest power of x? 4x to the fifth. Is there anybody else that's x to the fifth? No. So we have 4x to the fifth. Maybe I should do that in a different color. Let's do that. 4x to the fifth. What's next? Anybody else with x to the fourth? Nope. Okay. Next. X to the third. So we got a negative 10x to the third, and then another negative 10x to the third.
Negative 28x to the sixth.
Close. X to the third. Remember, when you're adding and subtracting, the exponents don't change. Only when you're multiplying do exponents change. Or dividing, technically. Next. X squareds. We got 2x squared and negative 15x squared. Negative 13x squared. Any plain x's? 25. That's the only one. And then the last piece. And there we have our fairly large polynomial to deal with. This is at we call this fifth degree because the highest power is 5. So if I say that, I haven't really talked about degree yet, but if I say fifth degree, know that I'm just talking about the highest exponent. That's all that degree means. We're talking about a single variable in our problems. Let's do another one that's kind of interesting. It looks real innocent and plain, but it's cute. If we're squared, easy. Short, quick, should be. Cubed, what does cubed mean?
Multiply it by itself 3 times.
Yeah, so we've got x plus 3 times x plus 3 times another x plus 3. So we got 3 of them to do. Now, what's the best way to eat an elephant? One bite at a time, right? Okay, so this is our elephant. If you're a vegetarian, think huge salad. One bite at a time. Okay, so the bite we need to take is one that we know how to cut apart, right? So if I were to take these two and say, okay, pretend this is not there, we know how to do that, right? So let's do the part we know how to do. Well, that part's still there, but we're going to do this part in the brackets first. It didn't matter which two I picked. I usually just start on the right and work my way across if it's like this. If you pick these two together, it's going to give the same answer. I just picked 2 of them, multiply them together. So if I multiply these two together, x times x is x squared plus 3x plus another 3x plus 9. That part we know. And then can we simplify this part? X times x, x squared, x times 3 is 3x, 3 times x is 3x, 3 times 3 is 9. That's where those parts are coming from. Got combine like terms in the middle there. Not exactly necessary, but at some point it's going to have to be done anyway. Or maybe you know that shortcut to squaring a binomial, that you square the first term, square the last term, and then multiply them together and double it in the middle. Because x squared, 3 squared, 3x times 2 is 6x. That's the shortcut. It didn't take that long to do it anyway. But now what? Distribute again. I'm going to distribute x plus 3 to all of those terms. So I'm going to distribute x 3 times and 3 times. X times x squared, x cubed, x times 6x, 6x squared, x times 9, 9x. And then distribute the 3. 3 times x squared, 3x squared, 3 times 6x, 18x, 3 times 9, 27. And that's a positive 3x squared, so it's like a plus sign in front of it. Notice how I've stacked them there. If it's already in descending order, sometimes that's a good option as far as organizing it goes. That when you distribute the first thing, that's that top line. And when you distribute the second thing, that's the next line. If there were a third thing to distribute, you put it underneath there. And you line up columns with like terms. Sometimes that can be helpful. When we do a really long one in a minute, that's going to help us from not having to have like 2 pieces of paper. Okay. So x cubed, nobody else like an x cubed. So he comes down, or she, I'm not sure. And then 6x squared plus 3x squared, 9x squared, 9x and 18, 27x, and then 27 doesn't have anybody else like him. And there we've cubed a binomial. Raised it to the 3rd power. So itself times itself 3 times. All right. Not too bad. Not too bad. This is not extremely difficult stuff yet. It's tedious, and a lot of places you can make mistakes by just missing a sign or mismultiplying or misadding or missubtracting at some point. So you've got to be diligent and careful and persevere. What letter are we on here? K. Let's get a big one. 3x squared minus 5x plus 8 negative 7x squared plus 2x minus 9. Both of those quadratics, what we just spent a couple of weeks on, now we're going to higher degree polynomials. So we're taking 2 quadratics and making one bigger polynomial out of it by multiplying them together. So how many distributive properties do we have? 3. There's 3 terms here, so I'm distributing each term to this whole polynomial. Okay? And this is where that stacking idea is going to be helpful. So if these weren't in descending order at the beginning, sometimes it's really helpful to go ahead and put them in descending order at the beginning, even though it's not necessary. It can make it easier to do. Okay, so they're both already in descending order, which is a good thing. So the next thing I would do is distribute the 3x squared. So 3x squared times all of those. So that'd be negative 21x to the 4th plus 6x to the 3rd minus 27x squared. So there's the 3x squared distributed. Now I'm going to distribute negative 5x. Negative 5x times negative 7x squared. Positive 35 x cubed. And notice I wrote that underneath the x cubed. Okay. Negative 5x times positive 2x. Negative 10x squared. And then negative 5x times negative 9. Plus 45x. Last step, or from the multiplying part, positive 8 times all those. 8 times negative 7x squared would be negative 56x squared plus 16x minus 72. 72 doesn't look right. There we go. Now, total up each column for the final answer. 21, negative 21 x to the fourth, 6x cubed and positive 35x cubed plus 41x cubed. This one's got a lot of stuff, so negative 27 and negative 10 be negative 37 and negative 56. 93x squared plus 61x minus 72. What we're going to be building up to this week is taking this and being able to find all the zeros to that. And part of that is going to take some. I'm going to give you the skills to do that. There are some tricks and some things that can help us along the way to make that happen. Let's do. Get one with a couple of variables in it. Which a lot of people think these are harder. I think they're easier because you have less probability of having like terms at the end. And as far as descending or descending order goes, well, which letter are you going to go by? Doesn't matter. Okay, so I usually don't even grade descending order on these sort of things when there's two variables, because unless it tells you go by X and descend by X, it really doesn't matter because it's got two variables and one's no more important than the other. But it's distributive property, right? That's all it is. That's all we're doing when we multiply is distribute. 4x squared y cubed times both of those. 4 times negative 3, negative 12. X squared times x, x cubed, y cubed times y to the fourth, y to the seventh. All right. 4 plus 3. And then 4x squared y cubed times 5, x squared y. So 4 times negative 5, negative 20. X squared times x squared, x to the fourth, y cubed times y, y to the fourth. There's a understood 1 exponent on that plain y over there, if you ever wondering where that's coming from. All right, so we've got the 4x squared y cubed multiplied out. Let's multiply the 2xy out. 2xy times negative 3xy to the fourth. Okay. And then 2 times negative 5. Are there any like terms? We've got x cubed y to the seventh. There's nobody else like that. 4, 4, nobody's 4, 4. 2, 5, nobody else is 2, 5. Nobody else is 3, 2. No like terms. It's got two variables in it, so there's really no such thing as descending order unless we decide if we, if on a problem I say, hey, make this descend by x. And then you don't worry about the y's, you just go by x's. I usually don't. I don't do that though. That's the polynomial. Now, ones that have two variables, we're really just practicing that operational thing and exponent properties. we won't be solving those with two variables in Algebra 2. That would be more of a calculus type thing, which some of you will get to eventually, but Algebra 2 wise, we're not going to be solving two variables. We'll solve one variable, like polynomials, but two variables. Let's see here. Let's combine multiplying with the addition and subtraction. All right. Here we have